So let's start with the visual acuity. What is meant by the visual acuity and what are the different types of visual acuity and how can we measure it according to the age of the patient? So as you may think that the children will not be able to say how much they can see. So are there any tests that we can do for them? That what will we see now? So let's first define what is visual acuity, as it is one or it is the most used test in ophthalmology. If we wanted to a solid definition for the visual acuity, this means that the spatial resolving capacity of the visual system. So if we wanted to simplify this definition, this can be the ability of the eye to see the fine details. But if we want to break down this definition, spatial is related to the space. So can I see, what can I see in the visual field around me? Resolving, so I will be able to identify what I'm seeing. Capacity of the visual system. So visual acuity simply means how much I can identify and separate the object located around the visual field around me. And if I can see much smaller details and I can see them clearly and separately, then I have better visual acuity. If I cannot see smaller details, then I have less visual acuity. So this is the commonest test used in ophthalmology by measuring the visual acuity. So the patient usually either stand or sit at 6 meters, or he can sit 3 meters and see a mirror that will reflect this 3 meters, so the distance, or so that the target will be above his head, so that he can see it through 6 meters. So it will be 3 meters one way and 3 meters on the other way. So this will be the standard. We measure the visual acuity against 6 meters, or the distance is 6 meters. So how can we measure the visual acuity? The visual acuity is based on the principle of a visual angle that we talked about in the optics, meaning that if we are looking to any target, this target has ends, and this ends will make an angle at the nodal point. This angle subtended at the nodal point is called the visual angle. In order to see the target or see the object, this angle should make an angle of called an angle at the nodal point of degree called 1 minute of arc. So what is the 1 minute of arc? If we continue this arc like this, so it will be eventually it will be 360 degrees. This amount is called 1 minute of arc. So it is just a smaller measure of the angle of vision at the nodal point. This amount is called 1 minute of arc. If the angle, or if the object subtend an angle of 1 minute of arc at the nodal point, it will stimulate the cones of the photoreceptors, causing appreciation of this target. So this is called the visual angle, and again, to see the target, we need at least the target will subtend an angle of 1 minute of arc to be seen separately. So what are the various ways to measure the visual acuity, and what are the different nomenclature for the visual acuity? We have different tasks of the visual acuity, and then so we have different types of visual acuity. To summarize these types of visual acuity, we have what's called the minimum detectable or the minimum visible. We have the minimum separable, or the resoluting power or the resolution power of the visual system. We have the minimum recognizable, or the ability to recognize objects. And we have the minimum discriminable, or the hyper acuity, or the vernier acuity. Let's see now what are the difference between these types and how can we measure them. First of all, the minimum detectable or the minimum visible. It is easy from its name to see to tell that it is just if you can see or not see the object. So it is required only to the presence or absence of the stimulus in the visual field. You don't need to know what are the different details or how to discriminate the target details. Just you can see or you cannot see. This is called the minimum detectable acuity. So, for example, if you can see a white circle in this black square, or this white line, this black square, then this can be considered as a minimum visible. Or the reverse, if you can see a black spot in the white square, or this dark line in the white square, this is considered as minimum visible. So you don't need to know what is the size, what are the details, just to see or not to see. This is called the minimum detectable or the minimum visible. The second one, which is the most one used in the clinic, which is called the minimum separable. Minimum separable or the resoluting power of the visual system, this is the most commonly used. In this case or in this task, the patient is required to localize the allocation of the gap. So he is presented several letters, and these letters has gaps or have gaps, and the patient is required to say where is the gap. Is it to the right? Is it to the left? Is it to up or down? And for this test, the patient or this test will depend on the angle that this letter will make at the nodal point. So this will depend on the visual angle, as the minimum angle of the minimum visual angle or the threshold is 1 minute of arc. If the patient can see, or the lesion or the type, or what's called optotype, make an angle of 1 minute of arc at the nodal point, then this patient can see the target. And this is the function of the fovea itself. So let's see. So there are two main types, or two main charts. We have the Landolt-C chart and we have the Snellen-E chart. Each one of them has a gap like this, and here is a gap like this and like this. So we can, by asking the patient where does this letter looks, then you can see or you can tell what is the visual acuity, because this gap is constructed to make an angle of one, or if it makes 1 minute of arc at the nodal point, then this patient will be seeing 6 or see the perfect vision. So this point or this gap like this and also like this will subtend an angle of 1 minute of arc, so that the patient will be able to see the black line and white lines are separate, and he can see the black and the white in between separate. So this is called the Snellen chart, and this is called the C chart or the Landolt-C chart. So the patient the patient task is to tell where is the gap. There is another task, or there is another visual acuity test. It depend on the minimum recognizable, or we don't, in this condition, we do not ask the patient to locate where is the gap, but we ask the patient to name the target. So what is the target? And they are usually letters or numbers, and they are large enough so that the detection here is not the limiting factor. We don't ask the patient to detect a gap, but we present a large letter, like ask the patient, this is letter F, letter H, letter L, and then we don't just the patient or the task required here is not to locate a gap, because not all letters have gaps, but to just name the letter. Finally, the most higher function is called the minimum discriminable. The minimum discriminable, or what's called hyperacuity, sometimes referred to as Vernier acuity. They love to ask about this concept in the exam. Vernier acuity or hyperacuity, meaning that it is a higher function of the visual system in which it can be able to detect the spatial position of segments in the space, such as a break in a line or discontinuity in a contour. So, for example, let's see this example before we continue. You can see that both these two lines are in the same direction, or in the same line. But if we break this line, so there will be an angle between both of them. How minimum is this the angle that you can still detect that this line is broken? As again, the angle of displacement. So these two circles are displaced from each other. What is the minimum value of separation between these two circles that the patient can detect? Surprisingly, although the angle of the minimum angle of resolution is 1 minute of arc, but it was found that the Vernier acuity in some patients can, or some individuals can have a resolution of about 2 to 10 seconds of arc. So it doesn't even continue 1 minute. It is 2 to 10 seconds of arc, so that it will be as about 5 times as fine as the minimum separable. That's why it is called hyperacuity, because in this condition, the individual can see things that even cannot be detectable by the minimum acuity, by the minimum separable. It was also thought that the stereopsis, or the looking, or the stereopsis is the higher grade of the binocular vision, so that we can detect that the objects have 3 dimensions. It can be considered like an hyperacuity type, or can be considered as a type of minimum discriminable vision, as it has a threshold of few seconds of arc. The mechanism for Vernier acuity or minimum discriminable or hyperacuity is still unknown up till now, but this is the concept about it, that we can see a break in a line or separation of a contour or discontinuity in a contour in the space. So let's now talk about the measurement of the visual acuity. How can we measure the visual acuity? This can be done by what's called optotypes. An optotype is a single letter that has certain dimensions, as we will see now, that is used to measure the visual acuity. Snellen has invented some of letters that are named after him. They are called Snellen letters. So what are the Snellen letters? The Snellen letters are constructed so that the critical detail or the stroke width subtend one-fifth of the overall height. So if we divide the Snellen segment into 5 segments, 1 and 2 and 3 and 4 and 5, so each segment, either black or white, they will have a 1/5 of the overall height. So this gap, which will be 1/5 of the overall height, and this step is 1/5 of the overall height, and this gap also 1/5 of the overall height. So the ratio is 1 to 5. And again, this is the same thing with the Landau-Tessy chart. The gap in the C will be 1/5 of the overall chart. And this is intended because there is a theory of the visual acuity that will explain that we will see only, or the minimum threshold for the angle of resolution is 1 minute of arc. This theory is called the receptor theory, meaning that in order to see a target, or in order to see two sources that are separate, each source should stimulate one cone, and there is so let's say, for example, that this is a target and this is a target. In order to see them separately, if you see them separately, meaning that one target is followed on one cone, and the other will fall on another cone, and there is unstimulated cone in between. So if the image fell on two cones separated by an unilluminated cone, then the point of light would be provided as two distinct sources. So it was found that in order to see two separate targets, and the one cone and one in which one cone is in between, the minimum angle will be 1 minute of arc. That's why it was constructed like this, because in this configuration, in this 1 minute of arc will be fall on one unstimulated cone, and this will fall on a cone, and this black will fall on the cone. So we'll be able to see that this is a black, and this is black, and there is a white in between. And also in the Landau-C chart, the gap here is subtending 1 minute of arc, so that the black part of the C above it will be fall on one cone, and the black part of the C below it will fall on one cone, and there is one separated cone in between corresponding to this wide gap, so we can see that this is an opening here. So the letter itself will subtend an angle of 5 minutes of arc. So don't confuse between the gap and the letter. The letter itself has 5, or its length is 5 times the gap. So the gap will make an angle of 1 minute of arc, while the letter itself was making about 5 minutes of arc. This also, as we said, it will be at the measure of 6 meter distance. Again, the gap will be making a 1 minute of arc. This is the E optotype, and the letter itself will making a 5 minutes of arc. So this 1 minute of arc, it is called the minimum angle of resolution, or MAR. So the minimum angle of resolution for normal individual is 1 minute of arc, and that's a 6 meter distance. So if we measure at 6 meter distance an optotype that will subtend an angle of 1 minute of arc for each limb of the E chart, so the whole E will subtend an angle of 5 minutes of arc, then this patient or this individual is called to have a visual acuity of 6.6 or 20/20. 6.6 by meters and 20/20 by feet. So this is called the minimum angle of resolution, and this will be the measure of the visual acuity. So in order to measure the patient's visual acuity, we just make a notation, and this or a Snellen notation, to determine what is the smallest letter that can be seen clearly. So is it this one, or this one, or this one, or this? So as we go further from the eye, the letter increase, and the angle subtended by the gap itself is increasing, so that this can denote the visual acuity of the patient. So if it is this gap is small, then 6.6. If it is increased to 6.12, the gap increases to 6.36. If the patient still cannot perceive it and they cannot see the gap due to there is no unstimulated cone in between both of the stimulated cones, so this patient will have less visual acuity of 660. So this is called the Snellen notation. Or let's know what are the types of notation, and how can we mention the visual acuity of the patient. The first type is called the decimal notation. For this example, this means that this patient is seen as in 12 meters what the normal individual see at 6 meters. And if in this example mean that the patient is see at 36 meters what the normal individual see at 6 meters. And this mean, or if the patient see this target, then this means that patients can see at the patient sees at 660 meters what the normal individual see at 6 meters. If the decimal, this is called the Snellen notation. The Snellen notation can be can be mentioned as decimal number. So the Snellen fraction can be notated as a decimal fraction, and just by dividing the both numbers over each other. So 6 is this is 1, 6 divided by the 12, then this is considered as a decimal of 0.5. 6 divided by 60, then this patient has a visual acuity of 0.1 by the decimal notation or notation. So this is the first kind of notation, which is called the decimal. The minimum angle of resolution itself can be used for notation. So the minimum angle of resolution, as we said, is expressed in the minutes of arc. The angular size of the just resolvable optotype is present, or normally it is 1/5 of the letter type. So it is the reciprocal of the Snellen fraction or the decimal acuity, meaning that the patient who has a 6/6 Snellen visual acuity has a minimum angle of resolution of 1 minute of arc, as we just mentioned. The patient who has a visual acuity of 6/12 has a minimum angle of resolution of 12 divided by 6, so it will be 2 minutes. So this patient cannot see with smaller angle of resolution. He can see on 2 minutes of angle of resolution. If the patient has 660, then the minimum angle of resolution will be 10 minutes of arc. So this patient has a large angle of about 10 minutes of arc instead of the 1 minute of arc in the patient who see 6/6. So this is the reciprocal of the Snellen fraction. So if you just divide the Snellen fraction, it will be the decimal. If we take the reciprocal of the Snellen fraction, this will be the logmar, or sorry, the minimum angle of resolution. The logarithm of minimum angle of resolution is used for research purposes, meaning that in order to use the minimum angle of resolution as a vision, we can take the logarithm of the minimum angle of resolution to mention the visual acuity. And this is the principle of the Belilov chart. The Belilov chart is based on the logarithm of minimum angle of resolution, and that's why there is a geometric progression of the size of the optotype and the spacing by about 0.1 logarithm unit, as it was found that these types of visual acuity charts are more accurate in detection of the visual acuity, and because they have the same number of letters in every line, and they have the proportionate spacing between the letters itself. So to show you what is the Snellen acuity chart. So here is the normal or the Snellen chart. The Snellen chart have single letter in the first line, 2 letters in the second line, 3 letters in the third line. So as we get more towards the smaller lines, they get more numerous. And sometimes in some charts, the space itself is not proportionate. So the space between the single optotype and the next one is not proportionate to the third line or to the fourth line. So this can affect the vision. And there is, in patients who have amblyopia, they have what's called the crowding phenomenon. So they see a single optotype better than if it is alone, it is better than if it is present within other optotypes in a line, because they have what's called the crowding phenomenon. So we want a better measure and better measure for acuity, especially as this will be done for research, so that the Belilov chart have been invented based on the logarithm of minimum angle of resolution. So as we get to the, as you can see that the larger line has 5 letters, and there is a space between each letter and the other. And as we get down, the letters decrease in size, but they have the same, the same 5 letters, or are always 5 letters in the line, and the ratio or the space between each letter and the other will be proportionate to the first line and the second line and third line, so they will be decreasing by the same ratio. There are different examples for the Belilov chart. It can be made on C chart or E chart or letters. And here is a table to show you the different notations either used in Snellen. And Snellen can be used by either a meter as a British system or in foot in the American system. So 660 equals 20 to 100. And by this patient will see minimum angle of resolution of 10. Logarithm of 10 will be 1. And by the decimal, so it will be 6 over 60, it will be 0.1. So this will be the principle, and we can apply it at any kind of acuity, like 6.6, like 6.30, or 6.12, or 6.24. So you know the principle now. Let's now talk about the factors that may affect the visual acuity. So we have the physiology is the science of theories and science of factors and science of tests. So as you go through the physiology, you will find a lot of theories, you will find a lot of factors that's affecting something, you will find a lot of tests to measure something, and you need to know this is the physiology. This is what you need to study. So what are the factors increase or decrease the visual acuity? So there are factors related to the stimulus itself. So you may find that we use the luminance of the test subject, meaning that if the test subject is very bright, this will improve the visual acuity. So it will improve, the patient can see smaller optotypes. But if the luminance of the test object or the test chart is minimum or it is dim, so it will logically the patient will not see the smaller optotypes. Contrast also has a role because, as you can see, that the visual acuity chart are always made from black and white, because black and white will be the best to white background, and the black optotypes will be the best contrast in order to see the visual acuity, or for the best visual acuity possible. So the contrast is important. Wavelength also important. Usually we use the visual acuity chart made of white light or monochromatic light, because because the white light or the monochromatic light shown to show the best visual acuity possible. This will be followed by the yellowish and others wavelength like the blue and the green. So the black and white will be the best option to detect the visual acuity. Exposure duration. It is logic that if the patient is looking to the target for longer duration, he will score better in the visual acuity. If we presented the chart for very minimum duration, this can cause the patient score to be less. Interaction effects between the two targets. So I told you in the amblyopia, the patient, if you present a single optotype in front of the amblyopic patient, he can see it. But if you put the same optotype in a line, then the patient may not be able to see it because there is an interaction between two single optotypes. There are some factors regarding affecting the visual acuity, but it is observer related. So if it is related to the patient itself, first of all, retinal eccentricity. If the patient is looking by the fovea, then this patient will see the best visual acuity possible, other than if the patient has eccentric fixation and looking by another part apart from the fovea. If the patient has a refractive error, this will decrease the visual acuity, of course. If the patient pupil size is very small, as you mentioned, it will limit the visual acuity by diffraction, and if it is very large, it will limit the visual acuity by aberrations, either spherical or the chromatic. Accommodation can affect the visual acuity itself, especially for the near vision. Eye movements also can decrease the visual acuity if the patient has nystagmus, so that the eye is frequently moving and the patient is not able to fixate on a target. So this will cause oscillation and visual acuity will decrease. Developmental and aging. Normally the patient is or the child reach the adult visual acuity at about after 2 or 3 years, and as a physiological process the vision will decrease as we get older, or the older population will show decrease in the visual acuity. Let's now talk about how to test the visual acuity, and this is an important part of the lecture. First, let's start by the children, and the children can be classified into pre-verbal and preschool. So pre-verbal, like the patients who are less than 2 years old, and preschools who are patients who are between 2 to 3 years old and 6 years old. So there are different tests to measure the vision in each one of them. First of all, there is a method called the CSM method, which is an abbreviation for central, steady, and maintenance. So what is the central, and what is the steady, and what is the should be maintained? This is the method for a very young, or the newborns, or pre-verbal children, in which we just test 3 functions. The C will refer to the corneal light reflex. As we know, the corneal light reflex should be central over the eye. So if it is central, then the patient has the letter C, or we can score the patient C. If it is the fixation target that the patient is looking at is not central, then it is called UC. Then the S. So what is the S? S means that is steadiness of fixation. So if the examiner is putting a light or a fixation target in front of the patient, can the patient has steady fixation over this target? And this can be tested uniocularly and binocularly. So how much this patient can make his fixation steady on this target? So not only looking at it, but making steady fixation on it. Maintenance is reserved for patients who have strabismus. So for patients who have strabismus, sometimes they have preference fixation. So if they have one eye is deviated and the other eye is orthophoric, then usually they prefer to see with the normal eye. So we cover each eye, and we see if the patient can maintain fixation in the binocular condition, or can maintain the fixation using the deviated eye or not. Meaning that if the patient has deviated eye like this, so that when we present a target or a torch, the patient can see it is fixing on the torch. And you want to know if this eye, which is deviated, can fix on the target as well as in binocular condition. So you cover the normal eye and see if this eye can gain fixation and become centralized or not. And this is called maintenance of fixation. So if the patient has central light reflex and shows steady fixation and maintain fixation, it is termed CSM. There is another term that will refer to the same process, but with a simpler form. Is called F and F, which is fix and follow. If the patient can fix on a target, and when you move the target, he moves with it, or he moves his eyes with it, then he can called be F and F, or can fix and follow. The other test, which is most commonly used, which is called the preferential looking test. Preferential looking test is a test based on the fact that the child prefer to look at a heterogeneous object rather than a homogeneous object. Meaning that if you present the child a target that has a pattern, he will prefer to look at it rather than a target that has a uniform or homogeneous pattern. In this condition, we use a black and white stripes, and then these stripes, if the patient can see it, then he will look at them. And if he can look at them, we can make these stripes narrower, so that the patient will again is tested. So if he can see them, then we can make them narrower and narrower until he loses his interest. This is an example. So as you can see here, the examiner is hiding behind the preferential looking plate, and you can see that there is alternating dark and white stripes, and the child is looking over it. And when we make it down, again, the child look at it, because the child prefer to look at a heterogeneous or a pattern rather than a homogeneous stimulus. So if you can see it, we can make these stripes a bit narrower. There is another portable form of the preferential looking test. It's called the Teller acuity cards, in which these stripes are put in cards, and we present to the child, and we observe if this child is looking at them or not, and we can make them progressively smaller. There is an electrophysiological test that to measure the visual acuity of the children or the potential visual acuity of the children. It is called the visual evoked potential. In this test, we put electrodes over the child heads like this, and then these electrodes are attached to a device that's attached to the monitor, and we present two types of stimulus or stimuli. There is either a flash stimulus or white flash of light to present in front of both eyes, or a pattern that's called checkboard, like the checkboard of chess. So it will be alternating dark and white square. So when the child is looking to these alternating dark and white squares, and if he can see them, this will induce stimulation of the visual system that can be recorded into a graph. So if the child can see it, then this can be recorded, and then we can decrease, or we can make this checkboard smaller in order to test for more visual acuity. So we can present it can report or the visual evoked potential. With this will be discussed in more details in the electrophysiology lectures. It will depend on the presence or the electrical activity coming from the brain or the electrical activity of the visual cortex in response to the pattern stimulus. This pattern stimulus can be alternating in checkboard or a square wave grating. Grating means that there will be alternating the dark and white bands. So if there is the VB is abnormal, meaning that it's abnormal vision, and it can be used for other purposes, not only for children, but can be used for amblyopia, cortical blindness, malingering, and others. Here is this is a flash stimulus, but the sign and here is a checkboard, and the checkboard can give a graph, and we will analyze this graph later on. So if the child can see it, then we can know what is the potential vision of this child. Another important test is used frequently in children. It's called optokinetic nystagmus. This can be done in the neonate, and this can be done by a drum called the optokinetic drum. In this drum, we rotate it in one direction, and they have different colored targets like this. So when the child fixates with one of them, then it will move into a single direction. Then, as a physiological response, when this object will vanish from the sight of the child, the eye will rotate will return rapidly. So this will lead to a nystagmus that has a two-phase and fro-phase. So it will be moving in one direction and then moving to the reverse direction. So that's by definition, it's called a nystagmus. This nystagmus has a slow following phase. So as the target is moving into one direction, the eye will slowly follow this target. And after the target disappears, the eye will return rapidly into the normal position or the primary position. So by making these targets smaller and smaller, and if we see that the patient will show the optokinetic nystagmus, then this means that the patient has good visual acuity. As you can see here, this can be done by images, or can be done again by alternating dark and white stripes. So in this case, the examiner is rotating this drum from above downward. So this child should show slow phase of movement of his eye downward, and then once the stripe that he is fixing on it is disappear, he will return upward rapidly. So it will be a rapid recovering phase. If the child cannot see it or doesn't show the optokinetic nystagmus, this then means that the child cannot see this optokinetic drum, so we can use a larger one. Another version of the optokinetic drum is called the Catford drum, in which instead of using dark and white stripes, it is used dark circles of variable size. So the dark circle is moving in one direction, and the patient will show an optokinetic drum or optokinetic nystagmus as well. Resistance to occlusion can also be a crude measurement for the patient's ability to see. So if the patient has amblyopia or cannot see with this with one eye, he will resist to occlude the normal eye because he is using the normal eye for vision. So if you try to occlude this eye, the patient will not be comfortable. So for example, this is a child who has left amblyopia. Sorry, I have right amblyopia. So this patient, when you occlude the right eye, this patient doesn't have any problem. So she is happy, and because she depends on the left eye for vision. But what happens when you occlude the left eye? Oh, she's crying. She is not comfortable because she is depending on the left eye for vision, and now she cannot see by the right eye as it is amblyopic. The Candy test is a test also can be used for children or younger than 1 year old. So you present candies of different sizes and different colors, and so if the child can see them, then he will pick up them. But please note that this test will need some manual dexterity. So the child should be able to use his hands, because if he cannot see his hands, he will not be able to collect them. So it is not logic at all to present these candies to a child or a newborn who has 1 or 2 or 3 months of age, because he will not be able to collect them. After this, we have the vision test in the preschool children. So in this case, we bring mostly stickers and bring images of familiar objects or familiar targets to the child and ask them to match between them and another reference card. So the first one is called the screening test for young children and retards, which is called sticker. In this test, the child is given this key, and he is presented a chart. This chart has different shapes or different pictures, and when the examiner is ask the patient to or point to one shape, then the child should point to the same shape at his key card. So this is called the sticker test, and all other tests are working by the same principle. The Cardiff acuity test, this test you can present also different shapes present on stickers. The key factor here, or the limiting factor here, is how wide is the line that used to draw these pictures. So the wider the line, meaning that the patient will have less visual acuity, and the narrower the line, so this means that the patient has better visual acuity. Allen picture cards, so this can be the same like a Snellen visual acuity test, but in figures and in pictures. So you present a chart of familiar targets like a bird, like a hand, and they are decreasing in size. So ask the patient what is this. So since they are the preschool, they don't know what are the numbers and what are the letters, but they should know what are the figures. So they can see that this is a cake, this is a horse, this is a car, and this is a cake as well, this is a hand, and this is a telephone. I guess it is a telephone. It's an old telephone. So this is just the preschool version of the Snellen visual acuity test. The Sheridan letter test, in which the examiner presents a letter. This letter is either H or O or T or V or X, and he is sitting at 3 meters from the child, and the child has a key card again that has several letters, and he should point to the letter that is similar to that with the examiner. K-picture test, it is also used the same principle, so it is used for children who have 2 to 3 year old, measured at 6 meters, unlike the 3 meters of the previous test. It is based on the Snellen principle, so the chart is in the form of a spiral booklet. Here is the difference. With each page has a single picture with decreasing their sizes, like 660, like 66. So for each shape or each picture have different sizes, and the patient is given a key card and is asked to match with the picture as shown in the main card, meaning that the examiner hold this key picture test, which has like large fish and then medium-sized fish and small fish. Then they have large apple, then medium-sized apple, then small apple. And when we present each picture for them, the child hold this card and he should point what is the shape. So if the child can see the large fish, then we can make the medium-sized fish, then the smaller fish, and then we get smaller, or we get smaller as the child responds. So these are for the preschool children. What about the younger adults or younger children? So it's if the child is 6 years or older, then he can name the letters or he can understand the normal Snellen visual active chart. So we can use the Snellen visual active chart and present the normal optotypes, which should be each optotype will be subtend an angle of 5 minutes of arc, and then so we will present either the letters or the numbers or the E chart or the C chart. Then also the logmar visual active chart can be used, which is based on the minimum angle of resolution, which, as we mentioned, is more precise than Snellen chart because of the regular progression in size and spacing from one line to the other. Tumbling e-test is a test using the minimum separable distance, in which the child or the patient is asked to identify where is the gap, as well as the Landau-Tessier chart or a broken ring, in which the child or the patient is asked to identify where is the gap. So they are based on the angle or the principle of minimum separable angle, so that it should subtend a 1 minute of arc and the whole optotype should subtend 5 minutes of arc. So I guess that this is the end of the lecture. So do you have any questions? You can see that these are different lines. If you can see a break in a line, this is considered a type of vernier acuity. And also here you can see that this line is parallel to this line. So but these lines or the radiating lines here, making them appear as if they are not parallel. So this kind of vernier acuity, that you can see a break in the line or a break in the line like here. So I got disconnected.